The darken matrix is the same as the identity, except the resulting brightness of the pixel is only 80% of what it was to start with because it's multiplied by 0.8. In this one, the entire picture is made brighter by having each pixel multiplied by 1.5. This is just like the identity, except the multiplier is larger. Now this one produces a new pixel by removing some of the characteristics of the surrounding pixels and increasing the value of the pixel in the center. This last one heightens the contrast by sharply differentiating the new pixel from the ones around it and sharply increasing the value of the pixel in the center. These convolutions are a bit extreme, but they're meant to just show you how this thing works. Anyway, a new convolve op is constructed by using the kernel. The kernel was chosen, and a new buffered image is constructed by applying that filter to the normal buffered image. Then the newly constructed image is painted to the display. Remember, the buffered image is a subclass of image, so this method works just like it always has. Each one of these methods puts the address of an array in the selection for use in the paint method. Now, this collection of methods makes it possible for something outside of this class to select which one is used and which picture is displayed. Now, let me show you how that works. This is the main line. It lets you specify the image to be used, or it uses a default image. As you'll soon see, the default image is one that was chosen to show off the convolutions. Most of this you've seen before, but in this application, some buttons have been added to let you change the picture by switching from one filter to the next. It's really simple enough. A border layout manager is used to position the canvas at the top of the screen and position a row of buttons across the bottom. This method constructs the row of buttons. Each button is named the same as the convolution controls. Now, this is the method that's called every time a button is selected. It calls the image changing method that matches the button pressed. Here's the result. The normal button sets the convolution to the identity. This is the picture as it originally appeared. That means that the image displayed is the same as the one that came in from disk. Each of the other buttons chooses its corresponding convolution. It displays the image after it's been converted. As you can see, with each convolution, different characteristics of the image become obvious to the eye. It's this sort of image modification that's used to analyze the content of pictures. If you really wanted to make a sophisticated application, you could make one that allows you to dynamically vary the size of the matrix and set each of the values inside the matrix. If you've got any old pictures around that you'd like to enhance, this is one way to do it. Scan it in and play with it. The stuff is amazingly flexible.